Hello, welcome to College Algebra. I'm going to do a review of Chapter R. Chapter R in the book is not officially material for the 150 class, but it's definitely a good base to get started to make sure you have a good foundation. It's kind of a review of maybe Algebra 1 and Algebra 2 all wrapped up into that chapter. So it's a real good place to start and make sure you're comfortable with some of the concepts there. So I'm going to start in R.3, that section. R.3 is polynomials, just general polynomials. So I would like to first of all start with the exponent rules. The first thing, and if you want to follow along in the book, I know you'll have an online book as well as you could optionally buy the physical book, but either way you can follow along, and I encourage you to take your own notes so you'll have these whenever you get into your homework. But this would be on page 24 of the current textbook. Alright, so the exponent rules, and you'll notice in your textbook all important rules will be in green boxes, so that's kind of their way of saying here are the foundational important things you need to know, and then you'll see examples as you go through using those rules. Alright, so these are in a nice big green box. So the first exponent rule we have is the product rule, and it says if you have an a to the m times an a to the n, it equals a to the m plus n. So what that's really saying is when you multiply with like bases, you add the exponents. So for example, if we have 3 to the second times 3 to the fourth, because there's like bases and we're multiplying, we'll bring the 3 over and add the exponents to be 6, 3 to the 6. Another example with variables, x to the second times x to the ninth would be x to the 11th. So again, when we multiply and we have like bases, we add the exponents. The next rule is the power rule. It says if you have any base raised to a power, then raised to an additional power. So a power to a power, you multiply those. So that's the rule for that. An example would be 7 to the second raised to the third would be 7 to the 6th. Then that could be further worked out where it's actual numbers, we could work it out, but usually we'll leave it like that. With an exponent or a variable, let's say we have x to the third raised to the fourth, that would be x to the 12th. So again, powers to powers multiply. Alright, also kind of different parts of the power rule, that's considered the power rule, but so is this. If you have two parts inside of the parenthesis, so they're times, a times b raised to the m, then the a goes to the m and the b goes to the m. So if we had a parenthesis, say 2x cubed y to the second, and then we raise that to the third, that would mean by the power rule that every item in that parenthesis should be cubed. So this is when it's a monomial, this is times. Now when we get to binomials, we'll have to talk about that differently, but this is the power rule for a monomial, things that are times together raised to the power. Each part should go to that power. So 2 to the third, x cubed to the third, we multiply those exponents, and 2 times 3 multiply those exponents, y to the 6th. If we have a negative sign, let's say negative 2x cubed to the fourth. The negative sign that's in a parenthesis, that's the negative 2 as a number to the fourth power. When the negative is included in the parenthesis and raised to a power, an even power, it is going to be positive. So negative 2 to the fourth, you could work it out and call it positive 16, or positive 2 to the fourth, you could leave it like that, but the negative sign is going to go away because you're going to have an even amount of negatives. A negative times a negative times a negative times a negative will make it positive. Then x third to the fourth will be x to the 12th. All right. Another reiteration of the power rule is whenever it's a fraction. So still thinking about the power rule, if you have a over b to the m, a numerator and denominator, the power rule tells us both parts should be taken to that power. So a to the m over b to the m. So if we have, say, 3/4 squared, that means the 3 is squared and the 4 is squared. And you could either, sometimes they work it out if they're smaller numbers, I guess that's sort of the rule, but if it's a huge amount, they usually just leave it with the exponents. So that can go either way, so just depending, maybe the directions will specify that. All right, so that's the product rule and the power rule. The next rule is the zero exponent rule. So I'll call this rule 3. All of that was, second rule was parts of power rule. So let's say zero exponent rule. And it says anything raised to the 0 power is 1. Any real number. So pi to the 0 power. We don't do that too often, but just to make my point, it doesn't matter what type of number it is. Any real number raised to the 0 power is 1. 3 to the 0 is 1. 7 to the 0 is 1. Everything to the 0 is 1. Every real number to the 0 is 1. Now, if we say negative 3 to the 0, this negative is not in a parenthesis. Like I mentioned on the last example, you need to have a parenthesis around your negative sign if it's going to be part of what's happening out here. So this negative is not specified going to the 0 power, so it's like a negative 1 in multiplier in front of that. Just the 3 is to the 0. Otherwise, it'd have a parenthesis to say, hey, this negative is also raised to the 0, and it does not. So it's a weighting negative. It's negative 1 times 3 to the 0. The 3 to the 0, as we've learned earlier, is 1. Any number to the 0 is 1, and then we would multiply it by the negative 1. So the final output there would be negative 1. Now your calculator also knows this, so I always encourage you to work these by hand, know the rule by hand, but then also practice them on your calculator, especially if it's numerical to where you can. Sometimes with the variables, if I say what's x to the 0, your calculator's not going to help you, but the ones that are numerical, it's good to press in your calculator and practice with that. So if I say negative 7 to the 0, we're seeing that that's going to be a negative 1. This negative is a weighting negative. We do 7 to the 0, and then the negative sign comes on later. If I had a parenthesis around it, though, like so, negative 7, the actual number negative 7, the negative included as the base, and to go into the 0 power, that is just 1. That would be just any real number. Negative 7 would be one of the real numbers, so that would count. All right, so that is how I would handle that, and there's all kinds of examples using these rules in all kinds of different ways, so I encourage you to practice that. Let me show you a couple more. Let's say we had 3x to the 0. Again, here this 3 is not specified in a parenthesis, so it's a weighting 3 or a multiplied 3. So only the x's to the 0, which is 1, then 1 times 3 is 3. If I would have had a parenthesis around it, 3x raised to the 0 like that. As a matter of fact, that could have the entire alphabet in there and numbers and characters, whatever. As long as it's all in the parenthesis, it's saying everything in here is raised to the 0. That one you don't have to think as much about. Any base raised to the 0 is 1. It's just when it's not in the parenthesis with it, you've got to be a little more careful and do that second. All right, the next rule, and I'm going to go ahead and jump over, this is actually on R6, but I like to go ahead and finish all my exponent rules with you while I'm on this row. So that's rule 3, the 0 exponent rule. So like I said, I'm jumping over actually to page 55 and picking up the rest of the exponent rules while we're at it. So the next one is rule 4, what to do with a negative exponent. The negative exponent rule. And it says any base, that means any real number, to a negative exponent becomes 1 over that base to the positive of that exponent. So whenever we move this from being in the numerator or just regular, we move it down to the denominator, it changes the sign of our exponent. So for example, if I have 3 to the negative 2, that could be converted to 1 over 3 to the positive 2, or 1/9. If I have 6 to the negative 1, that's 1 over 6 to the positive 1, or just 1/6. If I have, let's say 3x to the negative 1, since that's in a parenthesis, all of that goes to the negative 1, it'd be 1 over 3x to the positive 1. Whereas if I have 3x to the negative 1 without the parenthesis, and trying to make a big deal of this because this comes up a lot, if this is not in the parenthesis, the 3 is a multiplier. It is not raised to the negative 1. It waits and this goes down to the denominator. So it'd look like that, or 3 over x. Another way, another example, what about a fraction? If I have 1/2 to the negative 1. So if it's a fraction, by the power rule, both parts of that go to the negative 1. So if we have 1 to the negative 1 and 2 to the negative 1, they both will need to switch places. So to make that positive, I bring it up. To make that a positive exponent, I bring it down. So in other words, with a negative exponent, when you move its position from numerator to denominator or vice versa, it changes the sign of the exponent. So what has happened here, it became 2 over 1 to the first, or just 2. So usually the quicker way to get to this, the shortcut is to just say if you have a fraction to a negative exponent, it's going to flip the fraction. So anytime you say a fraction to a negative 1, flip the fraction and it'll make it a positive exponent. So an example of that, if I was doing 3/7 to the negative 1, I would flip that and it would be 7/3 to the positive 1. If I have 3/5 to the negative 2, it becomes 5/3 to the positive 2, and then you could work it out. So that's the negative exponent. And then the next rule is the quotient rule. So rule number 5. Quotient, we know, means divide. So the quotient rule is what to do when we divide with our exponents. So the rule says a to the m divided by a to the n will be a to the m minus n. So when we divide, and it has to be like bases again, we subtract the exponents. So for example, if we have 12 to the 5th over 12 to the 2nd, because of like bases, we bring that like base over 12, and then 5 minus 2 is 3, 12 to the 3rd. If we have x to the 7th over x to the 3rd, 7 minus 3 will be x to the 4th. Now sometimes when you do this, if it would have been x to the 3rd over x to the 7th, when I subtract, I'm going to get a negative. 3 minus 7 would be x to the negative 4. So then I have to convert that from the last rule to 1 over x to the 4th, positive 4. And that would be the way you'd want it to be left. We never leave an answer with a negative exponent. Actually, you're always supposed to fix that by moving that base to the numerator denominator as needed. All right. Then they could get messy with this and have lots of negatives. Let's look at this. The rule says if you have like bases, subtract top minus bottom. So negative 1 subtract negative 7. You just need to be careful with all those negatives. That makes that plus. Negative 1 plus 7 is 6. So all of this comes out to be x to the 6th. All right, so that's how to handle division. One last rule. One last rule is the, I think it's actually even on R.7, so they've kind of strung these out through the review section. But the last rule with exponents, I'll call this rule 6, would be fraction exponents. And fraction exponents are equivalent to radicals. We can change a fractional exponent to a radical. If we have a base raised to an m over n, a fraction exponent, that can be converted to a radical. The base is what goes under the radical. The denominator of your fraction is its root, and then it's raised to that m power. So for example, 49 to the 1/2 power would mean that you're doing 49. It actually just means a square root, because the 2 means it's a square root, and then you're going to raise that answer to just the first. So that just means the square root of 49, or 7. And that's how we handle a fraction exponent.